Alright, today we're going to talk about friction. So this is kind of a review from last year, but we do need to know this. So there's two kinds, first off. So there's the kind you get when something's already sliding across the floor. So let's say you have here's a box, and the box is actually moving. It has some velocity. Well, that kind of friction, there'll be a friction between the box and the floor, that is called kinetic friction. Kinetic friction. Okay? And it is a constant. It doesn't really matter how fast the box is moving or anything. The kinetic friction is always found by friction equals the coefficient of kinetic friction times the normal force. That's it. Where the normal force is the force between the box and the surface that it's sliding across. So in this particular case, here's the normal force. Okay, here's gravity. Beep. And the direction of the kinetic friction is always opposite always opposite the velocity. So in this case, velocity is to the right, friction would be to the left. Okay. The other kind is called static friction. Static friction. Okay, this one's a little bit more complicated. Static friction is that force that you're fighting when you're trying to make something slide across the floor. So let's say here's another box. Let's say I'm giving it a push. I'm gonna push it this way instead. Push it that way. Okay. So I'm trying to push it that way, and it's not moving. It's like you're pushing it and it's not doing anything. So static friction is the friction you get that keeps things from moving. Okay. And the equation is a little more complicated. It's still actually the same format, but this time that equation is actually giving you the maximum static friction. So it's going to be the coefficient of static friction times the normal force. Here's the thing. Turns out static friction is always exactly how much you need to have a net force of 0. Period. That's it. So again, let's say I have this box. I've got normal force this way. Gravity is down. I'm just going to put mg this time. It's easier. And the direction of the friction is whatever the direction needs to be to keep the net force 0. So in this particular case, the static friction would be equal and opposite to how hard I'm trying to push. Now, it can go up to whatever this number is. So let's do an example. We're going to do an example. Here we go. Example. Let's say I have a box, and that box is, let's make it a really heavy box. How about 30 kilograms? Okay, that's a heavy box. And I am sitting here like an idiot trying to push this box. I have no idea why I would try and push a 30 kilogram box, but let's say I'm trying to push it, and I am pushing with a force of, oh gosh, I don't know. How about 200 newtons? I don't know if I could really push that hard, but let's pretend. Okay, that is what I can do. And the coefficient of static friction between the box and the floor is, how about 0.6, okay? And the coefficient of kinetic friction is 0.2. By the way, the coefficient of static friction is always higher than the coefficient of kinetic friction for any pair of surfaces. So my question is, number one, if this box starts from rest, does it move? Can I move it with this much force? So let's figure that out first. Well, I know that the maximum amount of static friction that this box could have, I guess F max, I guess it'd be F S max, but max is, yeah. Anyway, So I know that's mu s times normal force. I am pushing straight to the right. So when I draw a free body diagram of this, do this over here. Let's see, we've got mg. I'm pushing that way, and friction would be the other way for static friction. If it's static friction. Okay. Because I'm not at an angle or pushing on it with an angle or lifting up on it or anything, I know that the normal force is going to equal mg. So in this case, I'm going to get 0.6 from the static friction times 30 times 9.8. Or you know what? I'm going to make this easier on myself. Let's make it 10 for gravity, just because. Make it easier. So the coefficient of static friction is 0.6 times 300. Okay, and that is 180 newtons. Okay, so this is the most force that the static friction can apply. Well, that's less than how hard I can push. So I am going to overcome that static friction, and that thing is going to start to move. But just like the instant that it moves, we switch over into kinetic friction. So let's figure out how much that is. So the kinetic friction is 0.2 times the normal force. So the normal force is 30 times 10, 300. Okay, that gives me 60 newtons. So that would mean that the free body diagram switches over to, this is Fk instead. And I know what that is. That is 60. And this is 200 newtons. Newtons everywhere. Okay, so from there I could do things like I could find the net force, and I could plug that into F equals ma, and I could find acceleration, and I could do all kinds of stuff from there. Okay, what if, I don't know, I went and gave blood or something, and I can't push with 200 newtons, I push with 150 newtons. Okay, what would be the static friction? Well, the max I can have is 180. That's the max. In reality, the static friction will be whatever it needs to be to cancel this out up to 180. So in this case, the static friction is 150 newtons. Can go up to 180, but it will only go up to 180 if you push up to 180. Okay. So one last thing I want to point out before we go. I think I showed you this kind of conceptual graph here last year, but let's say I'm going to graph, like, this is the magnitude of the frictional force. This is the magnitude of, like, if you were pushing on that box, this is the magnitude of the force you're pushing with. So when you're not pushing, so I'm going to start at 0, the friction is 0 too. Like, it doesn't matter. I don't care. As I push harder and harder and harder, oops, come on. You know what? Actually, I should have a different color. As I push harder, the frictional force will push back harder. It will compensate. Okay? So these go up with a slope of 1 until you reach a point. This point right here, that's F static max. Smacks, apparently. Boy, it's really late. Okay. At that point, you have broken the static friction. The thing will start to move, and you will jump over into kinetic friction. But the thing is, remember how I said coefficient of static friction is always less than the coefficient of kinetic friction? That means that Fs max is greater than the kinetic friction. So what you get is suddenly the friction that is allowed just jumps down. And then after that, you're in kinetic friction, where friction is coefficient of kinetic friction times the normal force. And that's a constant. Like, it doesn't matter how hard I push after that. All I've got fighting me is kinetic friction. Kinetic friction. So this is why sometimes if you're trying to push like something heavy across the floor, like a dresser or a fridge or whatever, you'll push really, really hard, and then suddenly you'll start to move, and it seems really easy to keep it moving. And that's because it is. You had to push your hardest to get it going, but once it's going, you don't have to push that hard to maintain its movement fighting friction. Yeah. Now, that's all I really wanted to talk about tonight. So please check out your WebAssign problems. I'm sorry that it's been having problems lately. And come with questions to class.